Okay, same unit again. We've just kept moving a little bit further along the seawall. We're still in the Cretaceous Nanaimo group. And here we actually have an outcrop that looks kind of similar to the last one. It's weathered a little bit differently, but when you get your eye in, we have this layer at the base, which is a sandstone again. And then can you see this conglomerate layer coming in? So again, we have what you could call an erosional surface. This would be the bedding horizon with a coarser grained layer above a finer grained layer. So it's exactly the same kind of thing that we saw at the last location. But now I want to get a bit more into thinking about how does this form? What kind of environment were we in? Remember, one of the key messages from our 223 classes was that when you're looking at a sedimentary rock like this, it's a fossilized landscape. So you want to try and think about where you were in a source to sink system. Were we at hill slope deposits producing landslides? Were we in a river network, a delta? Or do you remember at the end of that system we went into a submarine fan where we were going off the continental shelf in a marine setting? We already saw a few locations ago soft sediment deformation that indicated to us that this rock was saturated with water as it was being deposited. And we've seen that it's deposited in episodic events. There are unidirectional flows here because we have cross-bedding. So these were currents under the water depositing saturated sand, and then another layer was coming in with this conglomerate on top that's been compressing them and in places creating soft sediment deformation. That's exactly the type of deposit you would expect to see at the end of our source to sink system in a submarine fan. So these are formed in the marine environment with sediment that's ultimately being delivered from the continental landscape. So you could look at some of these clasts, and there's a whole range of different lithologies in here, metamorphic, igneous, there's a bunch of different types, and you could interpret where in your paleo landscape these have come from. That sediment is being delivered to this continental shelf, this slope in the marine environment, and episodically that sediment is collapsing and flowing down. Can you see this pebbly layer looks like it's channelized. It looks like it's forming a kind of crescentric channel, and if we move along the outcrop here, it no longer continues. So now we're just back into sandstone. So this isn't a continuous bed that's going on forever. This is an individual channel. And if you think back to source to sink, these submarine fans will have individual channelized flows that are transporting material down the shelf. If you look right up, maybe we pan up, there's a really interesting feature that we haven't seen so far, and that's embedded within this sandstone unit. You can see these darker, rounder shapes, which are not a continuous bed, so they're embedded within the matrix, and they're weathering out with this kind of angular, platy, blocky weathering texture. This is actually mud. Obviously I haven't climbed up here, but we've seen other features that are the same thing. The composition of these round lobes embedded within the sandstone is mud. Can you imagine that as these flows are coming down our submarine fan, underwater they're forming big plumes, and we have material settling out. The front of that plume, that current underwater, will deposit the coarsest material and it's moving the fastest. Then as those flows slow down, you'll get cross-bedding in here as the sand is being transported by these currents. And then at the end, you'll have mud settling out. The finest material, those fine mud particles will stay suspended in the water column for ages, and then they'll slowly settle out. When the next flow comes through, it will whip up and rework all of that mud. And in the turbulence of the submarine flow, that mud will get compacted into mud clasts. So they weren't boulders or pebbles of mud that came from the continent. They're formed during the flow. And we call these rip-up clasts. Mudstone rip-up clasts. They're embedded in it, and they were formed by mud layers from previous currents that came down this shelf, depositing mud and whipping up the mud from those earlier layers and then compressing them into what we call rip-up clasts.